Alright, in this lesson we'll continue to talk about rational numbers, but first we need to go over what square roots are and how they relate to irrational numbers. Now, by the end of today's lesson, you should be able to find square roots of numbers and to classify real numbers. Now, I don't want you to think about irrational numbers or rational numbers right now. I want you to focus on square roots. And the way that we're going to do it is by considering the three squares shown below. Each square has sides with integer length. Remember, integers are negative and positive numbers that are whole numbers. The area of a square is the square of the length of a side. Because a square, this is going to be a really good drawing, square has all equal sides. So some of you would say, well, I thought the area is length times width or base times height. Well, the square has all equal sides, so really you're taking just the length or whatever, the base, and timesing it by itself because it has four equal sides. Or if you're timesing something by itself, you're also taking something squared. And that's why we call it squared, because in squares we just basically take one of the sides and square it like we did here. 1 squared equals 1. 2 squared equals 4. 3 squared equals 9. The square of an integer, which is a whole number that is positive or negative, is a perfect square. The inverse of squaring a number, so the inverse of taking 2 squared, is finding the square root. So for instance, if I take the square root of 4, that means what number times itself equals 4, which is 2. So basically, in this book, you may assume that an expression under the square root will always be greater than or equal to 0. So when you see something, so make sure that when you are taking the square root of something, to remember that it cannot be a negative answer. There are such thing as negative answers with square roots, but you will not see that as a 7th grader. You will see that later on when you take math in high school. So again, we'll come back to irrational numbers, but I would like to go to the next section where it's asking us to simplify each square root. So the square root of 144. Well, some of you have these memorized already, but if you don't, you have to think to yourself, what number squared equals 144? Because we're doing the opposite of taking the square of something. So I know most of you already memorized it, and the answer is 12. But how can we check our work? Well, if I take 12 times 12, it better be 144, and it is. Now, what happens when there's a negative on the outside? Well, Mr. Sand, on the previous page you told me that my answer is never going to be less than 0. Well, that's true, but that talked about when there's negatives underneath. This negative is just on the outside, so all you have to do is first take the square root of 81. So what number squared equals 81, which I know that is 9. 9 squared equals 81. So my answer is going to be 9, but since there's a negative on the outside, it's actually a negative 9. Okay, so this negative is just out here waiting for basically you to take the square root of 81 and make it a negative. Now, the first 13 perfect squares are below. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared, 9, and so on. So if you memorize these, they'll help you solve problems quicker, which is another word to say that is efficiently. So you should know, 144. Well, I know that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, the 12th number that I talked about, I know 12 squared equals 144. So my answer is not 12 squared. When I take the square root of 144, the answer is 12. Make sure you do not write this as your answer. That is wrong. You just write it as a whole number, 12. I think my voice just squeaked a little bit, but that's okay. Alright, we're going on to the next part. You can use the formula d equals the square root of 0.5, which is also a half, times h to estimate the distance d, so d equals distance in miles to a horizon line when your eyes are h feet above ground. Estimate the distance, so we're going to be trying to find the distance. So I already know we're going to try to find d. d equals the square root, so estimate the distance to the horizon seen by a lifeguard whose eyes are 20 feet above the ground. So I know that I'm just going to evaluate and plug it in. So I know 0.5 times h. Now what is h? Going back into my problem, h feet above the ground. Well, I know that the lifeguard is 20 feet above the ground. So I'm going to plug in 20 for h. Now when I go through this process, I have to do, we almost treat this square root as if it's a parentheses. So we first have to do 0.5 times 20, which is the same thing as saying 1/2 times 20, or the same thing as 20 divided by 2, which is 10. So d equals the square root of 10. Now some of you would start to think to yourself, well, what number squared equals 10? 5. Well, 5 times 5 is 25, so that wouldn't work. So I'll make it a little bit easier for you. There are no numbers that equal 10. That's why it says, or what numbers times itself equal 10. That's why it says estimate. We want a whole number here. So we're going to say the distance is approximately, we don't know yet. So the square root of 10, I need to start thinking about what that is close to. What about the perfect square 9? What's the square root of 9? Well, the square root of 9 is 3. Okay. What about the square root of, what's the next perfect square that comes after 9? Well, let's see, 9, 16. What's the square root of 16? 4. So the square root of 10 has to be somewhere in between these two numbers. So I would say that the square root of 10 is closer to the square root of 9. So I would say that the distance equals about 3, because the square root of 10 is really close to the square root of 9. Now, do I just write 3? Well, I would say we're talking about the distance in miles. So how far is this person away? 3 miles. Now, we're going back to irrational numbers, and it says back here, an irrational number is a number whose decimal form neither terminates nor repeats. So that means, and this is a great thing you can write in your notes, we talked about this in the previous chapter, rational numbers are repeating decimals, terminating decimals, which means they repeat or that they just end, can be written as a fraction, or they are, now we can add this part, they're square roots of perfect squares. Now what are perfect squares again? They're right here, okay? What's an irrational number, which is new to us? It's basically all the opposites. Non-repeating decimal, non-terminating, cannot be written as a fraction, and the square root of non-perfect squares. So all those numbers that aren't listed on here, so 2, 3, 5, 6, 7, 8, 10, 11, 12, 13, and so on, all those are non-perfect squares. So if they ever give you like the square root of 10, that's a non-perfect square. So I already know that this is an irrational number. Okay, so let's look at some numbers here and let's see if we know if they're irrational or rational. So let's take a look at this first one, the square root of 49. Well, if I go back here, I notice that 49 is a perfect square. And I know that looking at this table, which you should have written in your notes, if I try to take a square root of a perfect square, I should know that it is already rational. So that means my answer to letter A would be rational, because 49 is a perfect square. The next one, 0.16. So I want you to be looking also at your notes that you wrote down about what's rational or irrational. I'm pretty good at math, so I don't need to go back and forth through each slide, but let's take a look at 0.16 or 16 hundredths. And I know that this is a terminating decimal because there's no dot 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 after it or a repeating. So I know that this is also rational. And why? Because it's a terminating decimal. That means it ends. If I can erase. There we go. Now the square root of 3, boom, irrational. Well, how did you get that so fast, Mr. Sand? Well, I know 3 is not a perfect square, so I already know that it's irrational. And because 3 is not a perfect square, it's like I know what the answers are going to say. 0.3333 dot dot dot. That also means 0.333 is repeating. You can see the pattern, so you don't need to keep writing it. So I know that a rational number is a repeating decimal, so it is rational. The next one, negative square root of 15. Well, I already know that 15 is not a perfect square, so I don't even care about this negative. I already know I'm taking the square root of a non-perfect square, so it's irrational. And why? Because 15 is not a perfect square. The next one, 12 and 69 hundredths. Well, I know that this is a terminating decimal. It ends, so I know that the answer is rational because it's a terminating decimal. And the last one, 0.123456. Now, some of you may think that this is a repeating decimal because of the dot, dot, dot. The dot, dot, dot just means that we are not looking at a particular pattern here. It's just going 1, 2, 3, 4, 5, 6, 7. The dot, dot, dot doesn't mean that it's going to go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. We can see the pattern here where it goes 3, 3, 3, 3, but we don't know if this is going to repeat. So I would call this a non-repeating and also a non-terminating because the dot, dot, dot means it's never going to end. So I would say that this is irrational because it is a non-terminating decimal. So some of you might say, well, why is this one rational then if this one doesn't stop either? Because it's a repeating decimal. It can keep going on and on and on if it repeats and be rational. But if it doesn't repeat, which this to some of you may look like a pattern, but it's really not, because it does not stop, it is irrational. Now, I also wrote this or drew out this little concept thing for you to study for the test. So if you ever need to go back and look at this, you can find it in this video, or you can draw it in your notes. Basically, what this is what we've been talking about. These are called real numbers, and real numbers are either rational or irrational. And we already talked about what irrational numbers are. Those are numbers that can't be written as a fraction. So like let's say pi. You can't write pi as a fraction. What about 0.3127630 dot dot dot? That's just all random, so that's irrational. What about the square root of 17? Well, 17 is not a perfect square, so it's irrational. Rational numbers can be written as fractions, so like 2/3. They can also be repeating decimals like 0.9 repeating. They can also be perfect squares, the square root of 16, and they can also be terminating decimals like 0.25. Now, rational numbers are also included with integers, whole numbers, and natural numbers. So basically, you see all these colors here, with the green and the blue and the red and the orange. Basically, all of these things. Let me grab the highlighter here. Natural numbers, whole numbers, and integers are all considered rational numbers. They're all in the big group. You see this orange box going around all of them. That's because all of these are rational numbers. And we will spend most of our class talking about rational and irrational numbers. So I would like you to just copy this into your notes somewhere on there so you can use it as a study guide. Alright, so make sure that you study a lot on what is rational and irrational because that'll be a big part of your test. And just come ready for class with questions, and if you have to ask questions on this part or this graph, we can definitely go over that in class.